All right, so we'll get started with 10.5 today. Last class we covered 10.4, which was slopes and graphing with slopes. Today we'll look at equations of lines. Equations of lines. So the first one that we're looking at is our one that we actually used last class to graph using slopes. But since they mentioned it in this section, I'll just go ahead and just do the same thing. But if you look at it, they actually talk about graphing using your slopes in the earlier part of 10.5. Well, not graphing using your slope, well, graphing using your slopes, but also using this to graph in the early part of 10.5, which is what we already did, but I put it in 10.4. So if you see it in the early part of 10.5, then we talked about it in alongside of 10.4 in last class. Okay, so just dropping that in there. All right, and so y equal to mx plus b, where m is your slope. And once again, don't forget, we're talking about the number that's in front of x is your slope. X is not a part of your slope. And then the other number is your y-intercept. All right, so determine the slope and the y-intercept. So in the first one, y equal to 3/5 x minus 2. What's sitting in front of x is my slope.
3/5.
The other number is my y-intercept.
Excuse me, when you say the number, you mean the negative too?
Yeah.
Where you get the B from?
That's what they.
That's what it is at the top. Okay, I'm sorry.
Yeah. No, you're fine. You're fine. Yeah, you are fine.
So when we write this is how we're supposed to plug it in.
My
And
math
then,
lab, will let you know. They probably have a box that you'll type it in.
okay.
And so they
We
probably
just,
have.
I'm sorry, we need to be able to know how to identify them if they act. Is that what that is?
Say that again.
We not need to know how to identify them if they act. And
Right. If they were to give you this equation, you should be able to pick out what number is your slope or what number is your y-intercept.
okay, got it. Okay.
And also, I pointed out last class that this is not in slope-intercept form. But I'll stay right here unless the equation is solved for y. So when we look at this next one, I can't just pick out. Why is that not erasing for me? Okay. I can't just pick out what my slope is because my equation is not solved for y. So that's what I would have to do first. Take this equation and solve it for y.
So is there any mathematical work we have to do when it's asking us that? Is there anything we're supposed to be doing?
Well, what's your definition of mathematical work? Because
when it says m equals 3 over 5, would that be the answer, and b equals -2.
Yep. In this case, that's all.
Oh,
Yeah,
okay.
that's the answer. Yep.
So in my mind, I'm thinking we have to do some kind of adding or subtracting or whatever. That's what I'm
Mm-mm.
asking.
Yeah,
Okay.
that's why I asked you to make sure that I understood what you meant by mathematical work. But yeah, that's all they wanted in that case.
Oh, okay.
Mm-hmm.
All right.
Let me write this. All right. So looking at B, in order to pick out the slope and the y-intercept, we have to solve the equation for y. So we're subtracting 5x from both sides. And that'll be
The screen left.
all right. Y'all can hear me now?
Yes.
All right.
Yes.
Cool. Yeah, I don't know what that was about. So now to finish it off, we divide both sides by 9. And don't forget that this 9 has to go to each piece. And do your division. So y is going to be equal to negative 5x over 9 plus 11 over 9.
So that's the answer to that question.
Mm-hmm.
I'm just trying to. I'm a little lost. I can't. For some reason, my mind ain't working right this morning. I'm feeling lost.
What's wrong? Is there something?
No, I just feel like we're supposed to be doing something other than just. I don't know.
Oh, you doing?
I think it's that simple.
Yeah, I'm about to say you doing too much. Okay, I got you.
Yeah, in my mind, I'm thinking it's supposed to be something else that we're supposed to be doing.
No, like she said, it's just that simple. I mean, if all they ask you for is the slope and the y-intercept, I mean that's it. Yeah.
I think I just want to do extra work. Let me just slow down.
And you don't have to divide the 9 into the 5 or the 9 into the 11. No, it's all good.
Okay.
All right, questions on that one before we look at one more using your slope intercept. All right, so here we're going in the opposite direction. So before we had the equation and we found the slope and y-intercept, this time they give us the slope and the y-intercept and tell us to find the equation. But it's still a simple process. We have the slope and the y-intercept, slope and the y-intercept. And that's all we're gonna do is plug them in. So y is equal to 1/4 x minus 3.
I thought that was a 9. I looked up, I was like, where you get that 4 from? At the top, it looked like a 9 to me. Okay.
All right, questions, any questions?
So, and we don't have to be bothered with the 0, of course, because it's just 0. We just bring the 3 down, the -3 down.
Yep. All right. Everybody good with this before we go to the next thing?
Yes, I got it.
So this thing that I'm writing in red, you don't write that. This is just a note to myself. So all right. So the next form, we have y is a point slope form. So we have y minus y1 equal to m times x minus x1. Where m is your slope, and then x1, y1 is any point on the line.
Can I say that this is kind of intimidating?
Well, you just was complaining that it was too easy.
I
And
ain't
now,
complaining. Look, I was just confused before. I'm just like, ugh.
I can't do right. I can't do right. I tell you.
And then I feel like it's a Monday morning for some reason. I'm still half asleep.
I feel you on that one.
Are we supposed to write down that y equals 2x plus 1?
Nah, you don't have to write that down. I don't even know why I wrote that there. Somebody must have asked me a question from my last class. So yeah, that's not necessary. Thanks for asking that. So let's look at how we would use this.
Okay.
So we're gonna write an equation of the line that passes through, or passes line with a slope 2 and passes through the point -4, 6. So going back to this, we're gonna have a slope and we're gonna have a point. That's why it's called the point slope formula. And we're gonna plug in for your slope and for x1, y1. That's where the point comes into play. And once you do that, you simplify, and then you will have a line. So let me erase some of this stuff so we can walk through it. All right, so the given information is that our slope is 2 and our point is -4, 6. So that's what I wrote right here in the red. M is equal to 2. Does that say something?
Oh, no.
Okay. M is equal to 2 and x1, y1 is -4, 6. Any problems with that? So now we're going to look at our formula, which is right here, y minus y1 equal to m times x minus x1. And we're going to plug in what we know. So 6 is y1. So that'll be, so 6 is y1. M, our slope is 2. And then x1 is -4. So be careful, make sure you don't lose a negative. All right, so before I go any further,
Is it mandatory to put that -4 in a double, like in a parentheses like that, or
no, it's just as long as you know what's going on. I'm doing
okay?
that because that's how you would properly, write it as far as notation is concerned, because you would separate these two symbols. But if you wrote it like that, as long as you know that negative to a negative is going to turn it to positive, I mean, that's fine. It's your notes, you know what I mean? Yeah, but as long as you have this negative and you have this negative, you don't lose a negative, when you do your substitution. And you recognize a negative times a negative will turn into a positive, which is what's going to happen to us in a second. You're still in a good place. So anybody have any questions with the substitution before we look to simplify?
Y. And how we get y to be 6?
That's
That's just where it falls in the formula. I see it.
exactly.
Okay. All right.
All right. So, like I mentioned, negative to the negative turns positive. And we're going to distribute this 2. So that's why we have y minus 6 equal to 2x plus 4. I said 2x plus 4, 2x plus 8. And then to simplify it, we will subtract. I'm messing up all my stuff. I need to lay down. Add 6 to both sides so that we'll have y on one side by itself. And this will be our equation. Y equal to 2x plus 14.
Wait a minute. Let me see.
So our equation is most simplest form.
Okay. Oh, okay. What is this on the left side, the purple?
I was just talking about how now that it's in y slope intercept form, I can pick out what my y-intercept is and what my slope is. Remember we talked about that last class. And so my slope is 2, so that'd be 2 over 1, that means I'll go up 2, right 1.
Oh yeah. Mm-hmm.
Yeah, so it was just showing you how all this still translates to being able to graph it and all stuff like that.
Oh, okay, I got it. Because the 2 becomes the M,
Mm-hmm.
and the 14 would be the y-intercept, right? Yeah.
Mm-hmm. Yep.
Oh, okay. So it would be up to and over 14.
When you graph it, you grab the 0, 14 first.
Oh yeah, because that's on a Y.
And then from that 0, 14, you go up 2 and then right 1.
Got it. Okay.
All right, let's look at the next one. Just doing this thing again. Let me erase this stuff though. So we have write the equation of the line with the slope -2, 3 and runs through the point 5, 0. What's going on here? Oh yeah. All right, so our given information is right over here. They give us the slope of -2/3. Y-intercept, not the y-intercept, they give us the point of 5, 0. All right. And once you've established that, you go ahead and plug it into the formula.
Yeah.
Y minus y1 equal to m times x minus x1. Your slope is -2/3. Y1 is 0. x1 is 5. So now y minus 0 is just going to give us y. So we really don't have to do any work over there. But here we have to distribute this negative 2/3 to x, but then also to 5, that negative 5. So I did the work for that down here. So you're talking about negative 2/3 times negative 5 over 1. And all you're doing is multiplying across. So negative 2 times negative 5 is a positive 10. Then 3 times 1 is 3. So that's how we got this equation right here. So make sure we're okay. All right, any questions? All right, so next one, write the equation of the line that passes through 3, 4, and 5, negative 4.
I had a question for the previous one. We bring the x, just carry the x down because it's in the equation. We just attach it to it.
Mm-hmm. Yep. So notice when you go and look at that equation, that formula, y and x stays a part of the formula. It's just that y1, m, and x1 is what's going to disappear because we're plugging in numbers for them. But y and x, stays as a part of your formula, part of your equation, I should say.
Okay, y and x, because that's what you're actually looking for in the beginning. Is that why?
Mm-hmm.
Okay.
All right. Excuse me. I'll write the equation of the line that passes through 3, 4, and 5, negative 4. So notice in this case, as far as the given information is concerned, they gave us 2 points, but they didn't give us a slope, and we need a slope. So that means we're going to find a slope first. I'll go green. All right. So, whoa. So we have x1, y1, x2, y2. Remember we talked about finding your slope before. If you have 2 points that are on the line, all you have to do is call one of your points point 1, call the other one point 2, and then put them in this formula right here, y2 minus y1 over x2 minus x1. So plugging in our values accordingly. Y2 is negative 4, y1 is positive 4, x2 is 5, and x1 is 3. So plugging that in right here, we have negative 4 minus 4, 5 minus 3, which will give you negative 8 over 2. And m is equal to negative 4. All right, questions on finding the slope?
Still gotta write the
How you
equation.
get the -4?
Hold on. We have two in the same. Look, I think, was that Miss Yim first?
We
Miss
still gotta.
Yim.
I think so.
Do we still have to write the equation for that, or
Which, when you said write the equation, you talking about using the point slope?
yes?
Yep, because remember that was the goal to find the equation, but we need a slope in order to find the equation. So this is the first thing we have to do.
And how'd you get there? -4 is M?
-8 divided by 2.
Okay. All right.
All right. So this is our slope, this is our M. And so now we're going to use the point slope formula to find the actual equation. So remember, like your classmate asked, we found the slope, but they want us to find the equation. So now we can use either point, either one of these points to find the point, to find the equation of the line, because remember both of those points lie on the line. I'm just going to go ahead and use x1 and y1 because it's already labeled x1, y1 for us. Once again, it doesn't matter which point you use. We have our point and we have our slope, and we plug it into the formula. And so y1 is 4,
Wait a
our
minute.
slope.
Go ahead. I'm sorry.
Okay. Our slope is -4 and x1 is 3. Distribute that -4. That'll be -4x plus 12. And let's see if they ask you guys to leave it in that form. All right. So also make sure you pay attention to the directions. It may ask you to write it in standard form. I'll write this over here. Standard form is AX plus BY. I need more room. So standard form is AX plus BY plus C. Nope, equal to C. No, that's the general form, sorry. That's standard form. General form has the C on the other side, but that's standard form. So if that's the case, then they want your X term and Y term on the same side, and then your C term, your constant, on the other side. So the way we can do that, I would add 4x to both sides, so that the 4x will cancel. So that'd be 4x plus y minus 4 equal to 12. And then add this 4 to both sides. And that equation in standard form will be 4x plus y equal to 16. So if they ask for the answer in standard form, that's ax plus by equal to c. So that means you need to get your x term and y term on one side, or preferably the left side, and then get your term without any variables at all. That would be a constant to the other side. Question before we look at another one. Another condition that you may see. All right, so next one, write the equation of the line that passes through 1, -1 and is parallel to y equal to 2x plus 3. All right. So key here is that the line that we want to create, the equation that we want to generate, is going to be parallel to this line. If it's parallel to this line, then we need to get, or it needs to have the same slope. Remember we talked about that the other day as well. Lines that are parallel have the same slope. So looking at that equation of y equal to 2x plus 3, the slope is equal to 2, and a line that has that slope, the line that's parallel to that line will have the slope of 2. Remember, it has to have the same slope. So that's the slope we'll use. Remember, we want to create an equation of the line that runs through 1, -1, but it's parallel to this line right here. In other words, have the same slope. All right. We now have our point and we have a slope. So before we plug it into the formula, any questions?
Could you scroll down a little bit so I can get that little corner and that little bubble right there? Slope of what is that? Parallel? No, down.
Oh.
Right there. Oh, there it is. Okay, thank you. Okay.
All right, so now we're just plugging it into our point slope formula. Y minus y1 equal to m times x minus x1. x1, y1 is 1, -1. And then, like I said, we already established that our slope is 2, the same thing as the slope that was given to us from that equation. So y minus -1 equal to 2 times x minus 1. Negative to negative turns positive. So that's y plus 1. And to get that, to write it as simple as possible, you would subtract 1 from both sides. And they cancel out over here and on the left. And that should be a 3, shouldn't it? Yep, it should be -3. So y equal to 2x minus 3. Yep, because we distributed right here. Gave us a -2, subtract 1 from both sides. So it'll be a -3. Now, once again, make sure you pay attention to the directions as far as how they want your answer to be, whether they want it, in this form or like we did in the last one, the standard form. All right, questions, any questions? Do at least one more. All right. So the next one, we're going to write the equation of the line that passes through negative 4, 2, and is perpendicular to 2y equal to x plus 7. All right. So here the key is that the line that we want is perpendicular. Remember, the line that we wanted in the last example was parallel. So we just use the same slope. The line that we want here is perpendicular. So we want, let's say our slope is going to be negative reciprocals. Remember, we talked about that last class, negative reciprocals. That means you're going to flip the fraction and use the opposite sign. So the slope will be negative reciprocal. All right, so now the first thing we have to do is figure out what the slope is of this line. So we have to solve it for y.
For what?
So divide both sides by 2. And then don't forget on this right side, that 2 has to go to each term. One purple. All right, so we took that equation and solved it for y. So that means the slope of this line is 1/2. So that's what I wrote right here. But remember, we don't want that slope. We want the slope of the line that's perpendicular to that. So that means we're going to take the negative reciprocal of it. So we're going to flip it, which is 2 over 1, and then use the opposite sign, which is negative. So that's how we got -2. So make sure we're all right with that.
Okay, 2 seconds.
That is the slope of the line that's perpendicular to the line that was given to us. So negative reciprocal. You have to flip the fraction and use the opposite sign. So we had 1/2. We flipped it. They gave us 2 over 1, but it was positive 1/2. So that means it had to be -2 over 1.
Oh my God.
All right. Oh no. Oh, here. Okay. So now that we have a slope and we have our point, which was given, we can use the point slope formula once again. Y minus y1 equal to m times x minus x1. Our slope, we said, is -2. That point they gave us is -4, 2. Let me make sure I wrote that right. Yep. -4, 2. So we plug that in accordingly. So that'd be y minus 2 equal to -2 times x minus -4. Always make sure you don't lose a negative because it does matter. There was a minus sign in the formula and we plugged in -4. So that negative to a negative would turn positive. But when I distribute, -2 times x is -2x. Negative 2 times positive 4 gives us negative 8.
So -8.
So that'll give us y minus 2 equal to negative 2x minus 8.
So equal.
Now add 2 to both sides. 2's cancel on the left. Then on the right, we have negative 2x minus 6 as our final answer. Once again, don't forget to make sure you pay attention to what way they want your answer to be. They want it in standard form. And you will add 2x to both sides.
Would it tell you what type of way we want?
Yeah, they
Or
should.
just,
Yeah, they should. Yeah. It should say, like in the directions I see in the book, it says write the answer in standard form. So, yeah. So standard form for this one, we would have added 2x to both sides. So that'd be 2x plus y equal to negative 6.
Standard form 2x.
And then if they ask for this one is slope intercept. Yeah.
And
Any questions? Any questions? All right. Let's see how much time we have left. So this class lets out at 10, at 11, 10:45, 20 minutes. We can at least start functions. Start, where it go?
I had a question on the homework, Professor. Would we be able to go over that?
Yeah, let's start functions and I will do it before we close out. Yep. So I do want to at least get us into functions because got a certain amount of content I got to make sure you guys see at least.
what number is this? What number lesson?
This one is going to be 10.6. So this will be 10.6 functions. All right. So definition of a relation. A relation is any set of ordered pairs. So in this case, We have 1, 2, 3, 4, and 5, 6. That would be a definite. That would be an example of a relation. Any set of ordered pairs. Your domain, set of all of the first components of the ordered pair or ordered pairs. So in this case, 1, 3, and 5 would be your domain. Your range, set of all of your second components of the ordered pairs. So in this case, 2, 4, and 6. Anybody still holding on to range? Okay. The distinct differences are between your domain and range, like we already mentioned. Your domain is your first component, your range is your second component. And if that's the case, that means your domain will be your x variables, range will be your y variables. Your domain is considered your input, while your range is considered your output. Your domain will be your independent variable, range will be your dependent variable. Then also when it comes to your axes, your domain will be on the horizontal axis, your range will be on the vertical axis. Everybody's still holding on. All right. So definition of a function. Function is a relation in which the elements from the domain corresponds to exactly one element in the range. So once again, a function is a relation in which the elements from the domain corresponds to exactly one element in the range. All right. So here we want to
Give me one
determine.
second. Could you go up a
Okay.
little bit?
Yeah.
Right.
Mhm. Yep.
That's good. I'm good. Thank you.
All right, not a problem. So we want to determine whether each relation is a function. Let me erase this stuff so we can upload. So determine whether each relation is a function. This first relation is 1, 6, 2, 6, 3, 8, and 4, 9. So it will help us to do a little bit of a mapping as to what goes to what, and that will be able to help us see what is a function, what is not a function, according to the definition that was given to us. So we have 1, 6, 2, 6, 3, 8, 4, 9. And so my domain is 1, 2, 3, 4. Remember, that's the first component in each. Range is 6, 8, 9. That's the second component in each. All right.
So we wouldn't double the 6, right? Because it's
Right, because it's already shown. All you have to do is show it once. Mm-hmm. All right, so when we look at 1, now remember what you have to ask yourself is the value that you're looking at in the domain going to only one value in the range? Okay, so if you can answer yes to each one of those elements in your domain, then that means it is a function. So when I look at 1, it goes to only 6, so the answer is yes. Now when I look at 2, 2 goes to 6 as well, but that has nothing to do with the 1. You're asking yourself, is 2 going to only one value? And the answer is yes. So it's
I'm not
3.
understanding because it's straight across.
Hmm?
Why are you saying 2 goes to only one value? I'm not understanding this part.
Well, how many numbers does 2 go to?
And it's only in one set right there.
I think
2
you're
and
going
6.
too deep. I think you're looking at it too deep again. So how many
Maybe.
numbers does 2 go to?
I'm not. I guess just the 6. 1.
Right, just 1.
Okay.
Right? And that's what we said a domain is. Remember the definition of a domain? I mean, not the
Right.
domain, definition of a function is that each element in your domain goes to exactly one element in the range.
I was too busy writing. I wasn't paying attention.
but you're good now though, right?
Yeah.
So we're trying to map. So what we're trying to do is make sure that each element in our domain go to exactly one element in the range.
So when would it go to 2 if it was 2 different numbers?
Girl, if you don't let me teach this class, I'll just mess with you. I'm gonna give you an example of that. I'm gonna give you. But right now we're just looking at this one. You want to make sure everybody's clear. When you do see a function, what it looks like. I'll show you what it looks like when you don't see one, when it's not a function though.
Okay.
But yeah, so when we look at this, each one of our values goes to exactly one element in our range.
Okay, got it.
And so even though this is repeated, that has nothing to do with the fact that 1 goes to one value, 2 goes to one value, 3 goes to one value, and 4 goes to one value.
All right, I got it now.
And
Thank you.
yeah, not a problem. You know, I just mess with you because I can. So so that means yes, it is a function. All right. So like I said, try not to get caught up in, oh, this one is repeating and all that. You know what I mean? If you just analyze each one of them individually, you'll see that this is a function because each one of them go to one value in the range. So the next one will help us to clear up how it looks when it's not a function. Can I scroll up? Everybody still writing? Okay, I know. So if we have this relation, we have 6, 1, 6, 2, 8, 3, 9, 4. So my domain is 6, 8, 9. Range is 1, 2, 3, 4. All right. So when I look at the number 6 in my domain, it goes to 1, but it also goes to 2. So since 6 goes to 2 different numbers, And so that's what we're talking about. Our domain goes to two different numbers or more than one number. It's not a function. All right. Questions on that? So far we haven't done any calculations, just, concepts of what a function is and what it is not. All right. So general summarizations of what we just did there. So if you wanted to try to summarize something to help you see it better, this would be a way, but if not, just do what we just did. It says there can be a repeated value in the range, but no value can repeat in the domain. And so we're talking about, notice here the domain has a 6 that's repeated. It was not a function. Here we had a 6 that was repeated in a range, but that was a function. So that's what we mean by that, is that there can be a repeated value in the range, but no value can repeat in the domain. And the range can go to more than one value, but the domain can only go to one value. So that's also something that was shown in the two problems that we did. Any questions? Any questions? All right. Any problems with that before let's see. It is 10:40. Okay, so next class, there are like two things in this section that we want to finish off. So next class, we'll finish this off. Also, and I know we have a question on the floor, so I'm going to answer her question. Also, there will be room for you guys to ask more questions if you have them. So make sure you take advantage of that, because we're looking at closing out chapter 10. So next class, I want you to bring questions to class if you have them, so that we can knock those out. We have a question though right now.
Yeah.
And like I said, we'll finish functions on next class. What you got?
10.2, it was graph the pair of linear equations on the same set of axes.
Mhm.
This how the graphs are similar and how they are different. And it's y equals x, and another one y equals x plus 3.
Okay. All right. So did you have a preference on how to graph it that you wanted to see, or not necessarily?
I'm sorry?
Did you have a preference on how you wanted me to graph them? And the reason why I asked, because we have 3 different ways we can graph using the XY chart.
I mean, I guess that like just the most simple, basic way.
Okay, I can just do the XY chart. So let's look at the first one. Y equal to X. So whenever you're doing, and then with my math labs, you're going to do 2 points at a time. So whenever you graph using XY chart, you would just choose 2 values for X, plug them in for Y. choose two values for x, plug them in for x to find the corresponding y value. So if y is equal to x, that means when I plug in 0 for x, that means y is also going to be equal to 0. Then when I plug in 1 for x, y is also going to be equal to 1. Next, with y equal to x plus 3, I'll use the same 2 points. So plug in 0 for x. When x is 0, y is equal to 3. Plug in 1 for x. When x is 1, y is 4. So before I graph those lines, questions on what I did, make sure we're good.
Okay, I got it.
Take your time.
Yeah.
Didn't you tell me to wait a minute, or?
Oh, no. I was saying,
Oh,
yeah.
I thought you told me I was waiting for you. Okay, my bad. So now we're gonna graph both of these lines on the same plane. I think that's what you said directions wanted you to do.
Yeah.
All right. All right, so we got 0, 0, and 1, 1. So 0, 0 is our origin. And for 1, 1, I go to the right one, up 1. So that's that line. And for the other one, 0, 3. So I go 0, nowhere for left, not to the left or right for x, but I'll go up 3. So that's 0, 3. And right one up 4 for 1 and 4. And so it should look something like that.
All right, thank you, Professor.
Not a problem, not a problem. Anybody else before we close out today? Anybody? Okay. So once again, make sure you guys check out this homework. See if you have any more questions that you want me to tackle on next class. Even if it's something like you saw something in the notes that you want me to do another problem, like bring that to class. So and it's easy if you bring it so that we can streamline the time. Already know what you want me to do versus me going to look for stuff, and that'll help us save on time. You're all right.
And
So
Mr. Tucker,
yes.
could once you're finished, could you go all the way back up to the definitions?
Yep. So let me do this. So is everybody good? Everybody straight before we close out? All right. You guys have a great day. Be safe, and I will see you on next class. Let me stop the recording.